Have you ever wondered what would happen if you fell into a black hole? As you get closer, the universe around you starts to distort. Stars stretch into strange shapes, and time itself begins to slow down. At the edge of the event horizon, there's no turning back. You'd see a twisted, kaleidoscopic view of space as gravity pulls everything, even light, into the void. It's a journey into the unknown, where the laws of physics break down. Welcome to Infinity Networks, where we explore the wonders and mysteries of the universe. Hit subscribe and join us as we dive into the cosmos and beyond. Why did humans fall into a black hole? Both death and immortality. Suppose we take a boat, spaceship to the black hole, jump out of the cabin at a relatively safe distance. At this moment, we will begin to be attracted by the attractive force of the black hole. Because the attractive force of a black hole, so that all the cores around it, captured by body and matter, and form one by one around the black hole, rotating suction plate. But because it rotates very fast, almost at the speed of light, under constant friction, its disk temperature can even reach hundreds of millions of degrees Celsius and produce intense and lethal radiation. When we filter out the entire electromagnetic spectrum, after all light except visible light, you'll see it in the spectrum. The disk is showing a higher energy blue. So some of the images are shown in orange. It's just a color for brightness, rather than the true colors in visible light. This explains why do hotter stars, the reason why it emits a strange blue light. At the same time, we also see this wonderful Doppler effect. The light on one side of the disk will be brighter than the other. Due to material moving in orbit is very fast, one side is approaching us at high speed, so that all the light waves are superimposed, allowing us to receive higher frequencies. And the other side is rapidly moving away from us, causing the light waves to be stretched, so as to receive a lower frequency. And we also discovered that bending occurs behind the disk. This is Einstein's attractive force lensing. Due to the attractive force of black holes, it deflects the light, so that when we look in a certain direction, the object you see is actually located elsewhere. At the same time in front of us, the starlight seems to be slightly blue. This is because the black hole warps the space-time around it, make time relatively slow. So in our opinion, distant starlight seems to be speeding away. And there's a blocking phenomenon. And we will also see a bizarre aberration sight. Black holes seem to be drifting away from us. As we get closer and closer to the black hole, the light in front of us is constantly shrinking, and it squeezes the view. As we gradually accelerate into the black hole, by constantly chasing the light ahead, make the front look brighter and brighter, and it's hard for the light behind us to reach us. So it's going to get darker and darker. At this moment, when we look at a spacecraft in orbit, we'll find its flight speed will also gradually slow down. This is because of the signals that the spacecraft sends out every second. It will take longer to reach us. As time goes by, the moment we cross the attack plate, the disk seems to disappear from our view because of the attractive forces here. So that all matter. At this distance, can't stably orbit the black hole again, and starts spinning rapidly and is sucked into the black hole. Soon we will arrive at the photon layer of the black hole. In this area, all light is destined to fall into the black hole. As we get closer to the black hole, the people on the ship will see we're falling slower and slower, forever frozen in a world of black holes. Due to the light we emit, it takes longer to escape the black hole, so that the light received by the spacecraft, it's going to slow down until it disappears. So for the spacecraft, we'll never be able to see us cross the moment of the world. But for us, seconds after entering the photonic layer, we'll pass through the world of black holes. From now on, outside the world becomes ours. All of our past will have nothing to do with this universe. Even if we send signals to the outside world, you will never reach your destination, and lead to the starting point will become all objects, the final fate after passing through the world. So what happens when you cross the world? due to our current situation, still receive light from the universe. So at this moment, we don't even realize it. Have you crossed the world? And on a large scale, the attractive force of black holes, enough to isolate it from the outside. But at the local scale, at the edge of a black hole, spacetime is almost flat. Here, the curvature of spacetime is imperceptible. At the same time, according to the strange aberration seen, even if we are already inside the black hole, image of a black hole, that's only 15% of the field of vision. Other regions, you can still see a cosmic scene full of stars. As it falls faster and faster into the center of the black hole, it's the light that reaches behind us. It seems to be in our field of vision ahead of us. Contraction. The horizon from the back is going to get wider and wider. Even though we are moving away from the ship at a very fast speed, the spaceship behind, it's in the foreground view. They get bigger. Before reaching the center of the black hole, we will feel a sense of difficulty, the power of belief. They're tearing us apart. In our last moments of consciousness, we'll see body. It landed on the flat surface of a black celestial body and form a body after a fleeting 0.1 second. All examples will go to the center of the black hole. The journey is over for us. And for the spacecraft outside the black hole, we will live forever in the world, although modern physics cannot explain. After falling into the center of a black hole, what? But the current theory holds that the center of a black hole, it is the starting point of an infinite time and space rate. Maybe only when we unify the attractive force and quantum mechanics after getting up to truly understand the center of a black hole. So what happened? And as the most extreme celestial body in the universe, black hole, we're constantly pushing the limits of human understanding. Perhaps only when the grand unified theory emerges, we can truly understand the ultimate mystery of black holes.